Okay, we're getting into section 4 of your textbook, and so chapter 13, section 4. And with this, we are looking at ways that we express concentrations when we're talking about solutions. And so the first type is mass percent, often described so the mass of a substance in solution versus or all over the total mass of the solution. This is probably most commonly found in biology. Often biology, when they make solutions, they make like 20% solution by mass, or 5% or 0.5%. So usually in biology, um, that's a reference. It's often commonly seen in that form. Okay, another form of concentration that expressed would be parts per million. This is basically the mass of a substance in solution uh, by the total mass, but times 10 to the 6th. So it's usually you have very small amounts, often in ecology and environmental science. You talk parts per million as well as, and that's usually in solution. And then you can also have parts per billion, so obviously a very small amount of a substance in that solution. And then another way that you might see solutions expressed would be in a mole fraction. So you have the total moles of a solution, or in a solution, and then the fraction of that is the substance that you're interested in. So in some application, one needs the mole fraction of solvent, not the solute. So make sure when you're looking at the problem or looking at what you're solving for, it's clear whether or not you're solving for the solute or the solvent in that case. Then molarity, which you should be the most comfortable or most familiar with, is moles of solute divided by liters of solution. And we have covered this already in chapter 4. And since the volume is temperature dependent, molarity can change with temperature. So standard molarities are often given at 20, or maybe it's 25 degrees Celsius, but it does depend on the temperature of the solvent, whether the molarity is, how it's going to change. And then another type of concentration, very similar, would be molality. So molarity is moles of solute over liters of solution. Molality is moles of solute over kilograms of solvent. And so since both moles and mass do not change with temperature, molality, unlike molarity, is not temperature dependent. And that's often why molality is preferred for some calculations, because if you know moles of solute and the mass of the solvent, those things aren't going to change if the temperature changes. So it's actually quite useful. So how can we move between molarity and molality? Well, if we know the density of the solution, we can calculate the molality from the molarity and vice versa. And we're probably going to need to just practice some problems related to this, because I don't think looking at this diagram is going to be overly helpful for you right now. Now we are going to stop right there. You just have some problems in class to work on, and you actually have, I think, a few more than normal. So make good use of your time in class, and remember that we do have a lab on Tuesday, so prepare for that as well.